Hey guys, Novolite here, back with my second installment of Gravitime theory. This time I'm going to teach you how to make something from nothing. One more time, I'm going to need to ask you to give me the benefit of the doubt on this one and just think about it from our perspective. Think about it from the questions we still have about our universe and think about it in a manner that you try to remove your human anthropomorphic views on this place. Uh, a lot of what I'm going to say in this video is going to be even more counterintuitive than the last one, but it's really important for gravitime theory in order for uh, it to work, or in order for it to represent what we see in the universe. And what that means is that the universe is actually functioning on a hierarchical platform. Everything in our universe is made of stuff from a hierarchy of particles. And that hierarchy extends beyond just the particle map of our universe into the actual foundations of space itself. So for the second Gedanken experiment, I need you to close your eyes for this one and just listen to my voice for a little bit. It's not going to take very long. I want you to put yourself out in the middle of outer space. Then from there, imagine looking out and seeing all of the stars in the universe, everything that's there. Now imagine all of the matter in our universe uh, is no longer there. It's gone. This is just for the sake of the example. What do we still have left? We still have empty space. Empty space is not nothing. Empty space is empty space. And the reason why this isn't nothing is in order for any particle to traverse our universe, it must traverse a medium. I'm not talking about some crazy shit like the ether. No, what I'm saying is that empty space isn't nothing, it's empty space. It's a quantifiable realm. We've proven that it is a medium for both photons, which are massless, and even gravitational waves that we have confirmed using LIGO. So it's transferring information. It's a medium. Uh, it has the capacity for matter to still exist in it, even if matter isn't in it. Now I want you to take that empty space, keep your eyes closed, and get rid of it. What do you have left? Now you have nothing. What color is it? It's no color. It's not white. It's not black. It's nothing. True nothing is the foundation for our universe. And in order for anything to exist in our universe, you have to build the hierarchy. So how do you build the hierarchy from true nothing? You can open your eyes now. I've got some true nothing on the screen. If you're familiar with graphic design, you'll see this. But to spare your eyes, I'll go ahead and invert it so this is a little bit easier to view. Now put your mind's eye in this space of true nothing. You, in a realm of true nothing, you now no longer have a medium. There's no way to transfer information. There's no way for matter to exist because there's no foundational hierarchy. So the next part of this, I want to show you how we can manifest something from nothing. We're going to have to forego a few expectations and just assume that we have the ability to create these things in true nothing, even though we don't necessarily have that ability yet. Now in your true nothing, I want you to place a single point, one imaginary point. It's not mass, it's not a particle, it's not anything. It's just your imagination. It's just your simulator. Now, that imaginary point in this universe of true nothing has now become the bound of your imaginary universe filled with true nothing. And everywhere you point a line from that imaginary point will circle back to the same point eventually. Now, true nothing can't actually exist by itself either. The absence of matter, the absence of space, the absence of particles can't exist without matter. But it is the bound to the upper end and lower end of our dimensional hierarchy. So I'm going to skip past that for now. We'll come back to the dimensional hierarchy. What I want you to do next is then place a second imaginary point in your true nothing. It can be right next to your point. It can be forever away. It doesn't matter where it is, because the distance within true nothing between 2 points, if you only have 2 points, is still infinite. You have no basis, you have no parameter, you have no medium for creating a measurement. And so that you can have 2 points in true nothing, and there's still, between them, you will have a line of infinity. But even the lines between them, you can have an infinite number of lines between them. But they always circle back to each other or themselves. Even within this Gadankenexperiment, you cannot have an unbounded infinity. The concept of unbounded infinity is actually a fallacy, and there is no such thing. You cannot have an infinite system without a bound. Now, the bound to an infinite system also can't be the system itself. It has to be external from whatever that system is. Therefore, in order for our three-dimensional universe to exist, it must be bounded by the fourth dimension. So, continuing on our Gadankenexperiment, I now want to take you to the place where we add a third imaginary point. Now what happens? We've got these 3 points floating in true nothing. Now we have enough information not to create a plane, but to create a definable point. Remember, we're starting from true nothing, so the 3 imaginary points that we have here can't actually have a definable place within true nothing because they're bounded by themselves. They're bounded by infinity. To make a measurement or a coordinate system within this framework, we have to do a couple of things. First, we have to make all of the internal infinities equal to each other. We can do this because they have reference to each other now. So we say that the 3 internal infinities between these 3 points now are all equal. Once they're equal, we can then subdivide those infinities using a fraction. So we can just say 50% of the way between this infinity, we're going to have a perpendicular line that, and we can say it's perpendicular because we've created this imaginary equivalent triangle. So we make a perpendicular, again, a perpendicular imaginary coordinate along this infinite line where we just say half of infinity. We have half of infinity on this side and half of infinity on the other side, and then these three sides are all equal, so the center of these infinities are also equal, and the very center of those three definable infinities now is our first definable point in our coordinate system. In classical physics, you would call this the zero dimension, right? There's no length, there's no width, there's no height, but it is a definable coordinate now. So if we want to expand this definable coordinate to the first dimension, all we need is another copy of this imaginary structure with a definable point inside of it, and then we split that off to the side here, and we create another series of equivalent infinities. And those equivalent infinities are now, it's another set of equivalent infinities, not the same set. They don't have to be the same as these. They can be, but they can also be different. Either way, we have these two triangles of imaginary points in our universe full of true nothing. And then in between our two definable points with these definable coordinate systems, we can now say the space between these two coordinates, these 6 imaginary points, is also equivalent to each other. And so what we actually have here is an infinite number of these slices, these representations. There's not just 2 of these now. In order for us to have a line, we need an infinite number of points. But the infinite number of points has to be bounded. What is it bounded by? Well, in this case, is bounded by our imaginary points in true nothing. So now we can do the same thing. If we want to have a plane, we need another one of these. And this is going to get really complicated visually, so I'm going to try to bring this into 3D and hopefully get a good presentation on this so that you can get a feel for what I'm talking about here. Now with 3 of these, this is where things change a little bit to normal dimensional mechanics. We only need a third one of these imaginary coordinate systems to create a definable triangle. And classical physics really likes to go to squares when they talk about a plane, when they talk about a cube, and that's because they're much easier to deal with. They're much easier to quantify, and they're much more obvious to the human experience. A cube is very obvious. Triangles get a little more confusing mathematically, especially pyramid geometry, but the universe doesn't actually have a geometric shape. So to really drive home how this starts to diverge from classical mechanics or classical physics is to show that when you're creating a coordinate system from true nothing, you need a third one of these systems. And what that does is that gives us a third definable coordinate, and then we make all of the internal connections again equal to each other. They're every single one of these connections is still an infinity, but they're bounded infinities by these imaginary points. And so from just adding a third one of these coordinates, we can now create a triangle. But what happens? What comes out of this? We have an infinite number of points along this line. We don't just have now an infinite number of lines in this triangle. We also have an infinite number of points in an infinite number of lines in a plane, or what classical physics would call the second dimension. And this is where things start to get really interesting, because every single one of these definable points now also has nested infinities within it. And so we have infinities nested within infinities. If we want, this still is a ways from representing our universe. So we do this again we add another point, which builds a pyramid-like equivalent structure from our imaginary points. And each of those imaginary points, now we have 4 sides to our imaginary pyramid. And from within our imaginary pyramid, we also have 4 definable coordinates that we can use to make a 3-dimensional pyramid. So what do we have? We have 4 dimensions of definition from true nothing to create an anchored coordinate 3-dimensional system. Are you cross-eyed yet? Are you still with me? I apologize for the complexity of that explanation. I know that concepts like infinity, or even the idea of true nothing, are going to be more than most people, I think, can really handle. I'm going to stop the dimensional progression mechanics here. It's very difficult to represent a 4-dimensional object in 3 dimensions, and any attempts to actually do so by us are woefully short. If you look at the progression down, it's easy to see how an infinite number of planes form a 3-dimensional object. But to show how an infinite number of 3-dimensional objects in a 4th dimension of physical dimension of freedom, you can't represent that within our framework, within most people's minds, even within our universe. So any attempts to show a 4-dimensional object is going to only be a projected representation. And anytime we do anything in relation to a higher dimension, we have to understand that it's beyond our nested realm. It's outside of our system. But what this is also going to do in a later video is show you how our universe can actually be infinite through this paradigm, through this coordinate system and foundation, we can show how the universe we live in could actually go on forever and exist in an infinite space. This has all kinds of ramifications philosophically, scientifically, uh, but this mechanism for explaining dimensionality is more relevant to the mechanics of our universe because you'll see that it explains the behavior that we're observing in a future video. So I really appreciate your time on this one. I know I've probably lost most of you on this video. What I really want you to take away from this is the understanding that everything within our universe is bounded and it is relative. And these concepts are going to unfold to show that the things that are happening in our universe are happening on a four-dimensional level. So thank you again for your time. I hope you'll please like and follow and subscribe and all that shit. Like, I really need a signal boost on this. If you know any physicists or I feel like they're going to be some of the few people that can actually comprehend what I'm talking about. But if you did understand this, please let me know what you think. If you have any questions, please ask. And I'll see you in the next installment of the solution to dark matter and dark energy in our Gadankenexperiment number 3.